Hello everybody, this is Cameron Snow with Danomics.com. So in this video, I want to demonstrate how we can utilize the new property modeling capabilities that are inside of Danomics. So let's get started. All right, the first thing you'll do is you'll bring in your data as normal, and then you will work that up in a petrophysical interpretation. So, we'll go through that normal workflow where we get our logs interpretation ready by handling all the aliasing and units and lithological corrections. We'll fix the washouts, and then we'll go through and we'll calculate all our key reservoir properties from clay volume through volumetrics. And once we've done that, then we'll be ready to start with our property modeling workflow. Now, it's just going to take a couple of steps. The first step here is that we are going to use some of our flow tools to come in and generate a log database that has all our interpretations locked in. This is a really simple process. We just point our flow at our log database. So we're just going to bring in our original logs. Then we're going to tell it which petrophysical interpretation to use. And then we'll tell it what properties that we would like to have available. So in this case, we have our normalized and edited curves here for things like gamma ray, resistivity, neutron, and density. We also have some of the key reservoir properties selected here, things like V clay, total porosity, water saturation, and so on. All we have to do is click the run button here, and that will then output a new log database that has all of these curves available in it. Then once we've done that, that's when we come to our new property modeling flow. So what this property modeling flow does is it takes our logs and converts those into a 3D volume. So we take the results from the flow that we just ran, we bring those into the flow. We then use our new logs to volume tool. And what we do here is we select our structure grids because we use those to define the top and base of our model. We choose what zones we want to use from that structure grid file. In this case, I'm choosing the Niobrara and the Frontier, but I could choose any of our zones here. We pointed out our well headers, and then we decide what property we would like to grid, how we want to do that interpolation, and we can set up some basics about our grid here. And then once we've done that, we just give it a name. And so here I'm going to call this VT final, and because I'm doing a total porosity volume, and hit the run button. And this only takes about a minute for it to run, and what we get out of it will be a new .volume file. And so that volume will be sitting right here. Sorry, it took me a minute to locate it there. And what you'll see that we have is we have a new 3D model, and we can come in here and it is fully interactive. You can scroll through it, and it really gives you the ability to see some really cool properties here. Like, so for example, here we can see that as we're moving into the basin, we have these high porosities here in the proximal part of our facies, and those are moving to lower total porosity as we move to the more distal parts of the basin. We can also see that our porosity is generally decreasing with depth here. So it gives us some really cool views that we can use to explore our data here. And everything's synced up, so as we scroll through the volume, you can see that it's moving the lines here on the map, so we can use our map here as a guide to know where we are. And it's a really powerful tool for geoscientists to use as a visualization. Now, of course, we're not limited to just properties like porosity. We can also use it for things like our gamma ray as well. So let's pop open a gamma ray model. Uses the exact same process. All we have to do is come back to this flow, and here, instead of using total porosity, we just point it at the gamma ray. And you know what this lets us do, and we'll put the vertical exaggeration up a little bit here, just so we can see it a bit better, is we'll now create that same model of gamma ray. And so, this really stands out quite well. We can see the high gamma ray facies here in the Niobrara formation as we're moving into the basin. It gives us a really interesting perspective here on how things are changing as we move basinward. So we can really see the consistency in our gamma ray signature there. So I think this is a really interesting view, and it gives us some new tools to look at and interrogate our data. If you'd like to get started on some 3D property modeling, give it a try. You can always set up a trial with us at sales@danomics.com. Thanks.